Right, I believe we are live. Welcome everyone. Welcome to another session of Amplifying F# Essential Lectures. As always, every Wednesday we cover a topic in F#. For this week, we have Ian, as usual, with a new lesson, which is going to be about processing external data. And in this case, we will be covering how to use the CSV and JSON formats, and Ian will expand a little bit more on that. But just to summarize, if this is just the first time you are watching this lesson on Zoom, we have been running this for now 6 weeks, and you can see all the previous content generated here on Amplifying F#.io F# Essentials. And if you scroll down to the part which says course overview, you can see here all the different lessons. Last week I just added the videos as well on each of the sessions. So if you collapse or expand the session, you will be able to see the videos that are here. So you can see the pattern matching session, and introduction to pattern matching and function is here, and so on. So yeah, for today, let's get into processing external data with F#. So Ian, the floor is yours.
Thank you.
All good.
Right. So up and running. So welcome to session 6. So the agenda for today is to do a quick recap on session 5, and then we'll start having a look at some external data. We're going to have a little play with type providers as well, which is going to be quite interesting. It's something that's not in C# at all, but it's a useful thing for dealing with data. So session 5, one of the main things I covered there was exceptions versus errors. So in C# in particular, and lots of other languages, exceptions are not the exception, they're the rule. So when things go wrong in any situation, you throw exceptions, which is great, but lots of things are not really exceptions. There are different degrees. So what we try to do with F# is yes, you can still throw exceptions, but exceptions should be for exceptional circumstances, not for things that you expect to happen. What we try to do instead is to use business errors. So exceptions we handle with you can handle with try with expressions. We can match the expression type. There's various other things that we can do as well that are quite useful. But what we tend to do instead is to return a result type, a result discriminated union, where you're on the happy path or the unhappy path. We do that because you can create discriminated unions for errors very cheaply, and they're just as well, they're probably more informative than exceptions are anyway, because you don't have a lot of baggage that you don't need. So they only carry the stuff that you actually really need to solve your problems. We then looked at console applications. So I'm just going to quickly close this and quickly open an example up. So I used some code from the appendix in my book. So I've just added a file to a folder. I'm just going to highlight the code that's in there and run the selected text through a terminal. And what it's going to do is create a console app for me. And also it's going to create a solution, it's going to create a console app and a test project as well. And it's going to add the console app to the test project. And it adds all the packages that I need, so XUnit, etc. And it will run the tests as well at the end. So there we are, we're up and running. So for my my thing. I've got a console app with a program file inside it. So I'm just waiting for it to catch up. Right, so there are two modes that you can run in for F#. So this is the real F# mode, if you like. So when you're creating applications, you should really run in this mode, but you can also run in the standard Explorer mode as well. So if I want to add a file, it's much easier to do inside this form because I can right-click on a file and I get a menu and it allows me to add files above or below. So files in F# are ordered just like the code is as well, from the top to the bottom. So if I add a file below, and I can't see, sorry, because I've got the Zoom menu there, I get the little pop-up window. I call that badfile.fs. So what I now get is I'm getting an error inside the program.fs, and it's talking about files in libraries having namespaces or modules. So I'll get on to exactly what those are in a second. And bad file, because it's the last file, isn't really a problem. So I can move it up or down with the arrows. So I'm going to move it up and out the way. And hopefully that will clear up that clears up that error. So the program file doesn't have to have a namespace, but any other file has to have a namespace. So namespaces are just like namespaces in the rest of .NET, except in F# they have a very specific meaning. The only things that can live inside a namespace are types, type declarations, or modules, and that's it. And inside a module, you can have everything else. You can have let bindings and types and other modules. So you can start by having a namespace. And then I can have a type like just put discriminated union. I can put that type inside a module. Oops, if I could spell. But then I have to indent the code that's inside it. So F# is a scope language. So that type of Boolean is inside the my module. So that's namespaces and modules. So I can add, as I said, I can add files by right-clicking and adding file above or below, and then I can move them with the arrows. I can also move them via the menu as well. Obviously, I can rename them. Now, if I go to add a file inside of the Explorer view, obviously I'm not ordered in this. Just because bad file starts with a B, it comes before P. This is obviously in alphabetical order. So if I add a new file called, go back to here. So if I had a new file above called zebra.fs. Same namespace, doesn't have to, but it's normally a good idea to keep the namespace the same on all the files. Now, if I go back to my Explorer view, you'll see that Zebra's at the bottom. So this view is alphabetical. When you add a new file, so I'm going to add a new file now called not Zebra. .fs. To get the order of that, I need to actually edit the project file, and I need to put it in the right place. So I'm going to put it there. If we go back to this view, you see that it's gone into that order. So you have to, so generally you define your types will be defined before you use them, before your lets. So you tend to have your types more towards the top of the project, although they can appear all the way down, and your functions and modules further down. So it sounds like a very complicated way of working when you're used to just adding files into folders and having everything automatically compile. But it does stop you having things like circular dependencies. It just doesn't happen. So the compiler can help you with all of this. So if the compiler tells you that it can't find something, generally it's because it's in the wrong order. So either the file's in the wrong place or the code's in the wrong place and needs to move somewhere earlier in the program. So that's console app. And sorry, I also did. We also looked at tests as well. So this is an XUnit test. You write tests exactly the same as you do in C#. The differences really are that because we've got things like the double backtick, we can have nice names for tests. You can also put tests into modules as well. So you can group tests inside a module, and it's a much nicer to read. We looked at FSUnit as well. So rather than having assert.true, you have something that reads a little bit more like English. So you can have things like true equals true, or this value equals, or this value should equal this. So it reads much more naturally than assert.true. Your mileage may vary, so you might prefer to stick with the XUnit style, and that's fine. It works perfectly. There are lots of other test libraries out there as well that you could use. They'll all work with F#. So that's that for that. If I close the folder in here. Is there anything else I need to cover? Right, so the only other thing we got to last week was with the errors. We were looking at map error, and I had a bit of brain freeze. So we had this little function thing that a little function called upgrade customer that does three things. So it does get purchases, then it does try promote to VIP, and then it does increase credited VIP. And some of these return result and some don't. And what we did was we had a specific discriminated union error type for the get purchases and a specific one for increased credit VIP as well. And then we created one for upgrade customer that uses both of those. So when we do the upgrade customer, it returns a result of either customer or an upgrade customer error. And what we were doing was, if we get an error from get purchases, we obviously get a get purchase error, and we need to convert that to or map it to an upgrade customer error. So that's what the result.map error does. And then we get on to the last part of this, where I wrote it all out longhand to try and break it down, and then we try and work out where we need to go to. So the first thing that we need to do is, in the initial code, we had result.bind, and actually that's still valid, because if we look at it, if we remember the definition of bind, bind is so the difference between bind and map is bind is it has a function. You have a function that takes an A and returns a result of B or C, and the difference is map doesn't return the result, but the bind does. So if we look at the structure from match, so from line 39 downwards, ignore 41, 42, and 43 at the moment, although that does return a result. So we've actually got a result.bind there. So I can do that. So I copy this, comment that out for the moment. So if I do a result.bind, I then have that. So what I'm looking at now is what happens here is this looks like map error. If you look at it, it doesn't do anything on the OK path, but on the error path it changes the error to this. So if we have a look at the definition of map error, so map error has a function that goes from A to B, and it takes a result of C to A. So if I have a look at this, so if this is my match, I've got a result and increase credit of VIP that takes a customer, returns a result. So if I actually go and have a look at that, it returns a result of customer and increased credited VIP error. And the function part, the F part, actually would be easier to see if I did this in, if I wrote it in the way similar to this. So that actually goes like that. So actually we have a map error here. So I'm going to copy that again. But it's slightly different in this particular case than it was for the earlier version of it. So now this is map error. So that's my result. That's the data that I passed in. So if I write this out a little bit differently, so if I go customer, I'll do it in two goes. So what I've actually got is that. And you can shorten that a little bit. So if you see this particular type of style, you might probably write it like this instead. to make it a little bit easier to sort of style, where you've got a single thing being copied, a single thing being passed along the line, single bit of data that's just used from the the line before, from the function before. We can actually use a slightly different operator, and that's what I've done here, which is this composition operator. So this thing underneath is exactly the same as this. So that's what this thing actually comes down to. It looks a little bit complicated, and to a certain extent it is, but stick with this. So this is probably as hard as it will get, but there is a much nicer way of doing this. We'll meet in session 11 when we do computation expressions. So a lot of this will actually get hidden away from you, and it will get a lot easier to work with. But this is, as I said, this is probably the hardest thing we'll do over the course of these 12 weeks. So it's just understanding inputs and outputs and just trying to match them all together. Right. So that's why I had a bit of a brain freeze last time. So I got a little bit stuck. But as you saw, I put a gist up within 5 minutes of finishing. So it suddenly occurred to me what I'd forgotten. So what we're going to move on to is looking at external data. So I've got a little project with a load of stuff already written for this. So I'm going to start off with a SQL database. So I have a SQL Server database running inside of a Docker container, I think. Well, it might not be. I might be using the local version. And I've got Northwind installed. Those of you that have never used it, it's a sample database. It's not particularly good. It's certainly not how most people would design databases now, but it's a free database that most people have at least seen bits of. So I'm going to use a product. I'm going to use a NuGet package called Dusty Tables, which is written by a member of the F# community. So this is a nice little library that works really well. So this is a script file, and we can load, as you can see, we can load NuGet packages directly into a script. We can also load code files as well. So I've got my my configuration in a .fsx file rather than storing it inside each one of these. So it's just done in one place. So I've created a simple record for this customer, and it's got a load of options. So most of the fields are nullable, but not all of them. So we've made them string options. So what I do is get the connection string, and then we use the SQL module inside of Dusty Tables. So we connect to the database. It's not actually connecting at that point. All it's doing is saying this is the connection string that I want to use. So the order of things like connect and query don't matter, but obviously execute does, because that runs everything. So we connect, we then create a query. For those of you that have never seen SQL before, that is genuine SQL. I know people who have only used Entity Framework, have never actually written a line of SQL in their lives. It's a wonderful skill to have, even now. So I still don't trust Entity Framework even after at least 10 years of having been using it. I still prefer to write code myself. And then we execute, and what we're going to do is get the data out. So Dusty Tables has a load of helper things in there. So you get things like string or none. So it's able to say that if it's null, then it converts it to none for you. So we don't need to do anything other than that. At the bottom, we've got there's a built-in default arg, which is the same as using there's another function on the option module called default. So you can do option.default, and that allows you to do exactly the same thing. This is just a built-in function that does the same job. So it just says if fax is none, then convert it to an empty string. And then we're going to, and that returns execute will return an array. And all we're going to do is just convert it to a list. Sorry, it returns a list rather, and all we're going to do is convert it to an array. It doesn't matter whether it's an array or a list. It doesn't really matter. So I'm just going to run all of this inside interactive. And you should see at the bottom of the page, I'm getting live data from the database. So I can output it to JSON very easily. I'm just going to use the standard JSON serializer to do this. So if I output to JSON, and I go and have a look at customers original.json, find that I get JSON. I'll just format that. So nice and simple. So it's just using the standard .NET JSON serializer, nothing special. Works with records, works fine. Interesting bit there is customers original. It does the conversions from none to null for us by default. So that's using system.text.json. So there is an F# package called f#.systemTextJSON, I think it's called. Not sure if I'm using it in this. No, I'm not. So there is another package for that. Yes, they are F# systemTextJSON, and that allows you to do to have a lot of control over how F# types are serialized and deserialized. So the defaults are not particularly nice, particularly things like discriminated unions. So that makes things a little nicer for you. But in this particular case, we didn't really need it. So next thing, if you want to use a parameter or parameters, we've got SQL.parameters, and it takes a list of properties. So in this case, I've got the customer ID. I'm just passing in the ID that comes from the outs that I'm passing in. So if I take that, and then I can just run it against with a name that I know that exists, and I get the name of the company name for Chops. So when we got that customers.original, the output is based entirely on the names of the properties of the record, Now, if you wanted to change that, you obviously need to create your own type or have some form of way of the parser actually doing it for you. But we've got another way in F#. We can create anonymous records. So what I've got here is I've got exactly the same query as before, the select all from customers. And in this case, I'm creating a new output. I'm changing the structure slightly here in that I'm putting the address into a sub level, if you like, so sub property. So the way that we'll create an anonymous record is using so instead of having just the curly brackets, we've got a curly brackets and a bar. So there's a vertical bar there, and the same at the other end. So if I want to, I can now go through and I can do things like make all of this lowercase. Country. That was all right. Okay, so if I undo that, I'm going to go straight to the serializer and then just write all the text out to a customers.custom file. So run that and go and have a look at customers.custom. And again, format that. So that's coming out in a nice format. So when we get to session 12, where we start looking at the web, we're going to create an API, and part of that will be using anonymous records to generate this without having to define them up front. So it's a nice easy thing that's built in. There's some things that you can do with anonymous records, but you can't do everything you can do with a fully defined record, because obviously they're not defined. So they're designed for very specific purposes, and this is one of the things that they're really useful for. So that's JSON. So JSON, there's no real difference, to be honest, between F# and other languages like C#. You can do exactly the same. So we can do deserialization to a type, and we can obviously do serialize as well. So there's no real difference between them at all. So if I run all of that, so customers is now an array of customers, and I can export them. So have a look at customers output.json. Not very exciting. It's exactly the same. So yeah, so JSON's exactly the same. One thing that we can do though is this is a type provider. So type providers are it's hard to describe. They're ways they're tools that allow you to investigate data is their primary role. There are different types of type providers, but in terms of the data that we're talking about, allows you to actually investigate data on the fly. So what we have here is I create a type of JSON provider. So this is using the f#.data NuGet package. So I can create a sample JSON file. So customers.sample. And in here, I've put the types in, so I can specify types for what I think the data should come out as. And so yeah, so I can just load it. So I can just load the I can create the type, and then I can load data into there, into customers. So if I do that, right, so if I I'll comment that out for the moment. Let's just load all of this. So what I've got now is I've actually got access to the data. So this is the array. So I can do things like I can get the length, which is 91. I can do I can get access to any of the items within that array, and it's giving me typed access. So it's telling me the what the properties are that are available to me. So depending on how the type provider is written, you're allowed to dynamically delve into the data and have a look at it. So this is obviously very simple, but it's quite a useful tool to have and to be able to play with. So this is a what they call an erasing type provider. So there are two types of type providers. There's one called generative. So generative are things that it does exactly what it says. It generates types. It generates other things as well. But the idea is that you could then use those types and other things in other .NET programs. Now, this is not a generative. This is an erasing type. So this creates dynamic types on the fly. So this is only available inside this particular piece of code. So if you did it in a library, it would exist within a library. It's not available outside of the library. So it's not available to C#, for instance. This is just for F# usage. But if you get a piece of if you get a piece of data, you get the ability to investigate it. But at this level, it's not really useful. But if you imagine if you got a we're talking to a file here. What happens if you could talk to an API and you could just say, that's the API I'm talking to, let's go and have a look at what's available. And what it'll allow you to do is to work your way down a structure and to load data dynamically from that API. Now, at the moment, we can't do that because we're just loading simple data from a file. So this is just an introductory session. We're covering about 10% of what these tools will do. But it's just to say, this is what a type provider is. Go and have a look at it. So that's the JSON type providers. There are type providers for JSON, CSV, XML, HTML, There is a SOAP one out there somewhere. There's also one for Azure storage as well. So for tables, blobs, and queues, there's a type provider for all of that. That will work against Azure, whether it's in the cloud or whether it's the local version that you can install. That's a really interesting tool. So that's all I'm going to cover with JSON. Anything you can do in C#, you can do in F#, exactly the same. Next one I'm going to look at is Dapr. Now I started using Dapr back in 2011, I think it was, when it first came out, when it was first made available. You know, when it was a Stack Overflow database wrapper. It's a simple micro ORM that sits around the SQL database, and I really liked it. Somebody's written an F# wrapper around Dapr, and that works really well. So difference here obviously is that the usage is slightly different than it is in C#, but we'll meet this particular style of programming in session 11. The only thing that you probably shouldn't use with F# is Entity Framework. I know there are some people that do, but I sort of recommend against it. It goes against the ethos of F# because you have to have mutable data, and we try not to do mutable data. I think the tools that we have available for SQL are very nice. There are lots of them, and any database platform that you probably want to talk about, there is an F# library for it. And if there isn't, there's a C# one, a .NET one that you can use. Any questions on what we've done so far?
Not really. Just saying that yeah, type providers, they provide types, as you said. And also, you know, someone said the other day on Twitter, like, nothing beats the type providers when it comes to data exploration. You know, like when you really want to have a quick and dirty exploration, nothing beats the productivity with them. And yeah, we have one just now. It says, where are you reading the connection stream from?
I have a file. So if I go to my database.fsx.
That configs FSX, yeah.
So I'm reading it from a file. So I'm loading the file into this FSX file. It's just a connection string. So
okay,
in fact, it's not even that useful because it's using trusted connections. So there's not even a code there. So, but it just saves me having to write it everywhere. I can just do it once and just load it in. It's the same for all config like that.
Yeah, and also my experience with the entity framework, like, also it wasn't designed with interop in you know, in mind. It was just pretty much a library that was designed for C#, and that's it. So there's a lot of issues with interop, and yes, you can make it work, but you know, with the rest of the tools that we have in the F# ecosystem, I don't think we even need it. But yeah, you know, some people really want to reach to entity framework, that they can do it, but it's going to be with some hassles, I guess.
Yes. Unfortunately, it's not the nicest tool for dealing with F#, but you know, some people do like it. As I said, I've met quite a few people who've never written SQL, who've just used Entity Framework all the time. So yeah, it's a sad state of affairs. Right. Next one, CSV. We've already done a little bit of CSV, so this is just the same, basically the same as I did in session 4, I think it was. So I've got my customers.csv, which is John, Mary, Richard, and Sarah from, so our eligible, registered, and guest customers. So as some data. So I've created a simple type where all the data is strings. I then have an error type in there. So if it doesn't match what I'm expecting, then it's an invalid error. So all I'm doing is loading the data in, reading all the lines, skipping the header row, and then just mapping each row, so splitting it on the vertical bar. And then I've got an array pattern match, which basically says I'm expecting six bits of data, and just extract the data into those. And if they don't do that, then report it as an error. I am way across the page. I think I'm just so I'm just returning the customer ID. So I'm not actually returning anything else. I'm just returning that. Next week, when we look at a bit more pattern matching, we're going to find ways of doing conversions. So things like is eligible, where it's a 1 at the moment. We're just picking out a string where date registers should be a date rather than a string. And at the moment we can't do that, but we're going to be doing that as part of next week's session. So that's obviously one way of doing it. This is probably not a good way of doing it, to be honest. So if you have complete control over the data, yes, by all means go with this approach. It's the simplest to get your head around. It works. But CSV data doesn't tend to be nice and simple. CSV data tends to contain lots of things it shouldn't. So when you've got things like when you've got a proper comma separated set of values and you've got a comma inside a string, there are rules around all of this, and this doesn't obey those rules at all. So you want to use something else. So there are two options that I've picked up. First one is a CSV provider, a CSV type provider. So again, we load the fsharp.data NuGet package, and I create a CSV provider. And I load the customers exactly the same again. So I go and collect a file, load the data, and then I'm going to get it tells me that there are rows available for that, and then I'm literally just going to do a map, which then creates the output for me. Get rid of I don't need it. So let's load it in. Okay, something's got a little odd here. I'm going to kill the session. I'm going to kill the F-sharp interactive window, and then okay, just look at it, and I've loaded the data. So that is I can't remember what the RFC is for the but it's but it needs to satisfy. But there is a CSV RFC that you're supposed to work against, and obviously this does work with that. We use this. So I worked on a product which had lots and lots and lots of data ingress like this, and probably a third of the data that was coming in was CSV files of various kinds. And we use type providers for all of that. And it works really well. So quite surprised. I was expecting to have to replace it with something else, but actually it turned out to be really efficient and worked really well for us. So we were collecting millions and millions of data records per day. So we were dealing with thousands of CSV files per hour, and it worked absolutely faultlessly. Really surprised. The other thing we could do is we could use the CSV helper. Oops. Seems not to be wanting to work. So why is that not working? Oh, okay. It's just the I think it might I think I might have upset my the compiler, which is why I'm getting lots of underscores. So I'll try and carry on.
I think you can reload the window. This is definitely a problem with F# script files. There's something weird with when you deal with the NuGet restores, it doesn't work correctly. I don't know. It's something specifically in the F# compiler, but
so stop sharing, close it down, and reopen it.
No, you can do I think it's Command Shift P or something like that, or Control Shift P, and then it will there is a
Control Shift B.
P of
oh no, that's put me
pineapple.
in go mode.
Yeah.
Ooh. So, that's
Control
scary.
Shift P as in Peter.
Okay.
All right. Control Shift P.
Yeah.
And then type reload window. Or there is also restart the F# compiler service, which also might be what you would like to do potentially. But yeah, there's something specifically about NuGet restores with F# script files that is not very good for IANIDE, and I don't know what it is yet.
Thanks, Jimmy. Yep, that looks like it's cleared up. Okay. Yeah, that looks fine. Right, so I've created a simple record type again. So all strings again, and then I'm using the CS3 reader class from in there to get at each of the individual fields. We can modify the config. So this is one of the, because it's a C# .NET library, it's automatically mutable anyway. So those little backward arrows are mutations. So I'm setting the delimiter to a bar. So I can't count on the number of things on my hand, the number of times that I've done that. And I even have gone to the stage of following what the thing told me to ignore. And what that is doing is saying, is the config delimiter equal to that? And no matter what the result is, throw it away. You will do it. You will do it often to begin with when you deal with mutability. Then you suddenly realize why your code isn't working, and it's generally because of that. Yeah, I've done that. I think everybody probably does it at some point. So that's just setting a few of the config settings. I'm not sure if they're absolutely correct, because this is this version of the CSV helper is a bit different than what I last worked on. So I'm a little bit in the dark on this one. So, but it does at least work in terms of it will load data in. So if I run that in interactive. And then if I load the data, I've got the data loaded in again. So that's a pretty standard CSV helper is a pretty standard CSV library for .NET. It works really well. It's very efficient. That's well worth learning if you deal with CSV files. Right, just got my favorite one to deal with now, which is XML. This is one of those that is pretty horrible. So one of the problems that you have with XML is that all of the XML libraries for .NET require certain things to happen. So they require that you have a default constructor. So you must have a constructor with no inputs at all. And also all of your data needs to be mutable as well. So that means that we can't use records, or can't easily use records with this. There is an attribute you can use called CLI mutable, but that doesn't work inside F#. That works outside of F#. So that's telling. So when you so if you want to share a particular a record, like a record type with some C# code, you can set it as CLI mutable, and it makes it appear to the rest of .NET to be a mutable class. But that doesn't work inside some F# code. So what I've had to do in this case is to create a class type. So this is an object. So the difference between an object and a record is obviously the structure is slightly different, but we've also got parameters that we pass. In this case, there aren't any. And I've also got mutable fields. I've got mutable backing data and properties set up on this. You can do it slightly less ugly than this, but I've deliberately done it as ugly as possible because I don't want people to do it unless they have to. Classes are great for certain things. This is probably not one of the things. I'd rather you find a different way of doing it than this. So we're going to load some data, and we're just going to serialize and deserialize XML, and that works fine. So that's pretty much the same as, so these two functions are pretty much what you'd write in C# as well. But we can use something slightly nicer, but it doesn't give you quite the ease of use that you get in C# of XML. So this is a library that I found a few days ago, which is called Fable.simpleXML. So Fable's a front-end JavaScript, TypeScripty type library or platform, I suppose it is now. And it's got lots of very nice little libraries written for it, and this is a really nice one. So this allows you to write to actually generate XML from a structure. So when we got onto the web in session 12, we're going to be doing this for HTML, and there are lots of little libraries that do exactly the same thing as this is doing with nodes. So it allows you to generate type safely an XML data structure. So this is using lists. So these square brackets are lists. So there are no attributes, and then the values are inside that list. So in this case, it's a leaf with attributes. We could have also done it down here as nodes. So it just allows you complete control over how you define your XML. So we could also have used the XML type provider, and that would do exactly the same as the type providers have done elsewhere. So you can load XML in and allows you to move around the XML. Right, so we got any questions on?
Yes, so we had one about the underscore source directory and also the attribute literal. So can you expand a little bit on that?
Okay, so I need to find one of those. Okay, so source directory is a built-in constant, I suppose, literal. So it's a built-in value, so it works out. So that will get converted into. So if I do. If I run that, you see it gets converted into path. That's where my code is running. And literal is we don't have constants. So that's effectively what a constant is in F#. So defining something as a literal is telling the compiler that it's something that won't change.
Yep, that makes sense. And also there are more, I think there are more built in like source directory, something else, but yeah, you can.
Yeah, there are a few built-in things like that, but I tend to just use source directory. It tends to be enough for what I use it for.
Yeah, we have another one regarding if type providers should be used in production or only for data exploration. And I will give my 2 cents. So I know people that uses them in production and they work really well, and there are a couple of them that are used in production. My company uses one of those. But personally, I think they are a really good tool for data exploration, but they need to be improved. They need to be improved and get better. But yeah, I would say, yeah, it's your own decision, I guess.
Yes, like all things. I mean, as I said, we use type providers in production, and they work really well. They're very efficient. The biggest problem really is that they're not always kept up to date. So it's sometimes you have to wait for things to catch up, so you can't upgrade as quickly as you maybe hope to. But yeah, as an exploration tool, they're unbeatable. But it's yeah. I mean, some people say don't use them. It's entirely up to you. I suppose the biggest problem really is that it's not really a problem. I mean, particularly the erasing ones, because they work on the fly. If something changes underneath, your code won't work.
Yeah, exactly.
So you're actually getting help from that perspective, although it may not be the help that you wanted. So yeah, it's a difficult one. It's up to you.
Yeah, I think there's a follow-up comment on David's question about the source directory thing, and he says that the reason he asked is because he has been unable to bind a variable to anything marked as a literal, and I guess that is not possible, right? You cannot bind a
There are certain things you can and certain things you can't. So you can't. Yes, you can't. It's meant to be once only. So things like source directory is compiled, is worked out once, so it effectively is a constant.
Yeah, yeah, and also says that the reason he's asking about the type providers in production is because sometimes you need to pass secrets on those type providers in order to, for example, I guess the SQL provider where you need to pass the connection string as part of that. But I think there are techniques that you can apply to maybe read that from a config file or something like that. So you don't need to actually pass the secret as part of what is visible. It can be hidden somewhere and you just load it from there.
Yeah, so against each type provider, so if I find that's not a type provider, is it? So against each type provider, there are various properties. So if you use a SQL type provider, for instance, the SQL type provider allows you to set the connection string. So the connection string could be retrieved from config.
Yep.
I would like to add my couple cents to that specifically. A lot of the SQL type providers will allow you to pass in some type of configuration for runtime specific things, but the things that we're showing here is typically something called like design time schemas, and so you usually have to give it some subset of data that you know will be valid in production. And that's usually the hiccup a lot of times is your data set that you're probably testing against isn't like real production data, and that's usually a bigger problem.
Yep.
But for instance, like SQL, the type providers, there's usually some way of saying, okay, well, here's my design time version. This is what we build against to give you the types. And then here's the connection string in production, which can be passed in at runtime and not a compile time constant.
Thank you, Jimmy. And I don't think we have more questions. Let me have a look. No, I think that's it.
Okay, that's as far as I want to go with all of this today. That's it's really a case of F# great with data. we've sort of the first 4 weeks we've been dealing with data, but in we already got it. This is about getting data from somewhere else. So the rest of the sessions will be generally about tying all this together. So getting data in, doing stuff with it, pushing data out.
Yeah.
Or even back again. So, and how all that fits together. So how you start to combine all these things together, how you test all of this as well. So if you've got, so you've got functions that get data, functions that write data, functions that validate data, functions that do other things as well. So how do they get structured? How do you then test the bits that talk to databases, that talk to, that read data in, all that sort of stuff. And then obviously, expanding on things like validation and all those sorts of things. So this is just a taster, really, just to say, if you need to get at data, there is a way of doing it in F#. If you can do it in C#, you can do it in F#.
Yeah, definitely. So I'm going to share my screen just to recap, what was the session today and what will we be having next week, if that's okay for you.
Okay, are you going to, I'll stop sharing. That's the easiest.
So yep, so we so that's it for today with Ian. So we, as Ian said, we cover really the how you can access to data, how you can consume that from external data. And so next week we will be covering let's have
More pattern matching.
more pattern matching. And let's see, this is one of my favorite ones. Active patterns is something that I really love in F#, and it's really underrated features. Like, I love this. It's so much nicer. And yeah, so we will cover in this. So I will publish the processing external data preview next week. So yeah, stay tuned for that. And you see, we still have more sessions to come, and we will have some bonus sessions from people from the community, giving us a little bit more of a real usage of what you can do with projects like Fable and maybe data science, mobile development, desktop development. So yeah, it's pretty exciting what we'll be having in the next after the 12 weeks of content. But before we go, I would like to mention that an Amplifying F# this week, we don't have the Friday session because our team is attending to the BOF.conf in Berlin. So we won't be hosting the session on Friday. So there's not a session available for you here. So just bear in mind that we will publish that onto the social. So you know that we won't be hosting the session. And if you value what we are doing here, trying to teach F#, trying to get the F# to the masses, and also the sessions that we have in Friday, consider donating us. A lot of people have already give us an immense support that we are really grateful for. So we're about to reach the first tier, the cottage tier that we have. And from 0 to 5K, and with this we can start doing more stuff for the community. We can pay we can cover our costs that we have been doing this for 2 years, and yeah, it's almost 2 years, and it's not free. It has some cost. So we will be doing some more stuff, covering our travel expenses, maybe distributing some swag, so coffees, t-shirts, and maybe starting to really work on open source and maybe pay the one person to working on issues with the compiler, with tooling and all of that. So yeah, thank you for that, and please consider donating us if you can afford it. Right, so with that in mind, thank you everyone. Thank you for another amazing lesson, Ian, and I will see you next week.